Welcome back, aliens. My name is Navin Reddy, and let's continue with this series on Python. So till this point, we have worked with operators, right? We have talked about assignment operator, arithmetic operators, and logical operators. Now it's time to focus on some more operators, and this time we are going to work with bitwise. Now, if you remember, in one of the videos we have talked about binary formats, right? So this is where you will use them. So for sure, the name suggests it is something to do with binary formats, right? So whatever you're going to do now is with bits. So let's get started. So let's open Python and let's do this calculation. Now the first one, so if we talk about bitwise, we have 6 different operators. We have complement operator, then we have AND, OR, XOR, left shift and right shift. Okay, let's start with the first one, which is complement operator. And if you look at the symbol of it, it's weird, right? We don't use this symbol much. So this is called as tilde operator or tilde operator. Now where you will find it? So if you look at your keyboard, just below the escape key, you have this special key called as tilde. So let's use it, and that's your tilde sign, and we'll give any number here. We will go for 12. Now when you say enter, what you are expecting? Come on, go for a random guess here. Maybe minus 12 or maybe minus 1, something like that, right? Now if I say enter, oh, we got minus 13. That's weird. Why minus 13? So let's do a research on this now. So let me go back to my paint and let's do the calculation. So how do you find this? Now to understand this, first of all, we need to find what is complement means. Now when you say complement, it will simply do reverse of your binary format. Example, if you say complement 1, it will give you 0. And if you say complement 0, it will give you 1. That's what it's doing. Now the same thing is applied on 12, right? Now, and what is 12? 12 is actually, if you convert 12 into binary format, you will get this. So you will get 4 zeros, 1100. That's your 12 binary format. And I love this mobile phone model, right? Nokia 1100. Everyone love it. Now we need to find a complement of it, right? So you have to find the complement of it. So what you will do is you will reverse the number. So this 0 becomes 1, and then this is 1, then this is 0, 0, 1, 1, 1, 1. So this is your complement of 12. But hold on, what is this number and why we got minus 13? That's weird, right? Now if you look at minus 13, why minus 13 is this number? That we have to find out that now. Now to understand this concept, again as a programmer, you need to know all this concept, because you will, so when you do any course in for IT or CS, this is what they will teach you in the first year. But if you don't know this concept, that's okay, you can learn here now. Now we have a concept of 2's complement, because what happens is in your system, we can store positive numbers, right? We can store 12, we can store 13, we can store 15, 20, 21, or maybe 1000. But how to store negative numbers? Now to store negative numbers, first of all, we don't store negative numbers in the system. We always store positive numbers. So even if you want to store this minus 13, you need to convert this number into a positive number first. And the way you can do that is with the help of 2's complement. Now how do you find 2's complement? So to find 2's complement, we need to find 1's complement plus 1. This is the formula, okay? So when you say 2's complement, it is 1's complement plus 1. Now how do you find 1's complement? It's easy actually. First, convert this number into binary format. Now what is 13? It's 12, 0, 0, 0, 0, 1, 1, 0, 1. This is a binary format of plus 13. So this is 13, okay? We want to find minus 13, right? So you have to find 2's complement of this number. Now let's find the 1's complement. And how do you find 1's complement? It's easy now. We know how to find complement, right? So we have to reverse this number. So you will get 1, 1, 1, 1, 0, 0, 1, 0. So this is 1's complement of 13, but we want to find 2's complement, right? So what you will do, you will say plus 1. Now this is, so when you say 0 plus 1, it will give you 1, and then we got 1, then we got 0, 0, 1, 1, 1, 1. Now this number here, this is minus 13, okay? So this is 2's complement of 13, which is minus 13. We got it. And now if you compare this number with complements of 12, they are same, and that's why you got. So when you say complements of 12, you got minus 13, right? So that was the answer. So that's how you can work with complements. So when you want to store negative number, this is what you do. Now I would recommend you to try different numbers here, maybe complements of 45, maybe complements of 121. So try it out and let's see what answers you get there. So that's your complements operator. The next one we have is bitwise AND. Now if you remember, in the previous video we have talked about logical operators, right? So in logical we have AND and OR, right? So here as well we can use bitwise AND and bitwise OR. So in AND, remember this thing. So whenever you have AND, and if you have two conditions and both are true, then only you will get true. And in OR, if you have at least one true, you will get true. If you remember. So if you remember this table, right? That's what you're going to do here now. So let's do bitwise AND. Now which operator we use here? So we don't use AND because AND is for logical operations. So here we have to use ampersand symbol. So let's take 12 ampersand 13. Okay, so we got these two numbers, 12 and 13. If I say enter, you got 12. But why 12? So let's find out using bitwise. So let's go back to our paint, and here we'll convert 12 into binary format, which is 00001100. This is 12's binary format, right? And then we have 13's binary format, which is 00001101. And now we need to find out the bitwise here, right? So we have to work with bits. So let's compare this bit with this bit. Now if you remember AND operation, if both are 1, then only 1, right? So this, in this case, this is 0, 1, so it will be 0. This is 0, this is 1 because both are 1s, and then we got 0, 0, 0, 0. And if you compare this output, this is 12, right? So you got bitwise AND. So this was an AND operation, and that's why you got 12. Let's do OR. So we'll say 12 OR. So now for OR we have to use pipe, okay? So for AND we have ampersand, for OR we have pipe. And then, okay, where you will find pipe, so it is above your enter button. So when you say 12 or 13, come on, guess. Now, in fact, before entering here, let's do calculation, let's compare here. So let's go back here and let's do some calculation. So it will be 00001100, that's 12, 00001101. That is your 13, right? And let's do OR. So when you say OR, if any 1 is 1, so your output is 1, right? So we got 1, we got 0, 1, 1, 0, 0, 0, 0. And that's your 13, right? So this is 13. Let's verify. And if I say enter, oh, we got 13, right? So this works. So this is how you work with bitwise AND and bitwise OR. In fact, you know, you might be thinking only 12 and 13 you will get, maybe some other number. Let's try. So I'll say 25 and maybe 31. Or maybe 30, yeah, 30. And you can see we got 24. Again, this is your homework, right? So try it on your notebook. So open your notebook and convert 25 into binary format, convert 13 to binary format, and just do AND operation. And of course, you will get 24. The next one we have is XOR. Now in XOR, what you do is, it's actually very simple. When you say you have two numbers, which is 0 and 0. Now since we don't have any 1 here, we will get 0. Then you have 0, 1. Now in this case, you have odd number of 1, right? So which is 1, 1. So you will get answer 1. Now when you say 1 and 0, so we have odd numbers of 1, which is 1. And when you don't have odd numbers of 1, you can see we have 2 1s, which is even number, so you will get 0. Okay, so when you have odd numbers of 1, you will get 1. If you want to remember in a shortcut way, it's very simple. If both the numbers are different, then you can go for 1, right? So we have 0 1 is 1, 1 0 is 1. So that's very simple. This is how you perform XOR operation. This is XOR, and you can represent that with the help of cap symbol. So let's do that here. Again, we'll take two different numbers here. We will go for, let's go for 12. Again, the same number, 12 cap 13 here. Oh, I just made a mistake there. 12 cap 13, and you can see the answer is 1. But why 1? Let's verify. So let's go back here and do calculations. So what is 12? We have done that, 0 0 0 0 1 1 0 0, and then we have 13 here, which is 0 0 0 0 1 1 0 1. And now let's do XOR. So if you have two different numbers, then 1, right? So they are different, 1. They are same, 0 0 0. All are same numbers here, so we'll go for 0 0 0. So the only answer you got here is 1, right? So that's why we got 1. That's how you perform XOR operation. So you can try here with different numbers, right? Again, the same number, 25 and 30, try it out and let's see what you get. In fact, I will do it here. So I will say 25 cap 30 and you got 7. But how 7? That's your homework, right? Let me know in the comment section what you get here. Now, once you have done with AND, OR and XOR, let's move towards left shift. I love this concept of left shift. So what is left shift here? So what I will do is, first of all, let me try something here. So I would say 10. Now when you say left shift, you have to use this left shift operators, which is left hand side. And then you will say 2. Okay, what's your guess? What is the output? I don't know, let's try. So you got 40, but why 40? Let's find out. Now when you say, let's go to paint here and let's do calculation. Now when you say 10, what is 10? Now I will ignore the earlier zeros, okay? So just because I'm damn lazy to write every time that. I will directly go with 1 0 1 0. So again we do have 4 zeros before, but ignore them. So we got 1 0 1 0, and then we have to apply a left shift operator here. Now, how do we use it? Now, in left shift, what happens is, imagine there's a box here. So imagine this is a box, and then we have a dot here, dot symbol, and then we have some zeros. Now, of course, right, every number is represented this way. Example, when you say 5, it's actually 5.0. In fact, we can have multiple zeros here, right? So when you say 65, it's again, we do have zeros there, but we ignore zeros because they are zeros. Here as well, when you say 1010, we do have a dot. So we do have a dot, and then after dot, we have multiple zeros. In left shift, what we do is we shift the bits on left hand side. Okay, I don't know from which side you are. So you are facing me, so for you, this side, right? So left hand side. So let's do that. Okay, so now, so when you say left shift, you have to shift bits. But how many bits? You need to shift 2 bits, right? Example, if you see the output here, so you are shifting 10 by 2 bits. So when you say 2 bits, you got 1010, and then you need to shift on left hand side 2 bits. So you will add 2 more zeros, then we have a dot. So we were having a dot after 0, but after shifting, you have shifted 2 zeros on this side, right? Now this number here is 40. Now how do you verify? Go with the normal calculation, right? 2 is to 0, 2 is to 1, 2 is to 2, 2 is to 3. So this 1 is 2 is to 3, and then we got 2 is to 4, and then we got 2 is to 5. So consider this one and consider this one. So this is 32 and this is 8. So 32 plus 8 is 40, right? So we got the answer. So that's how you find left shift. How about right shift? It's very simple. So we also have a concept of right shift, right? What I will do is I will go with the same number, 10, and right shift with 2 bits. Now in left shift, if you are gaining bits, in right shift, you are losing bits. Let's verify. So if I say enter, you can say we got 2. But why 2? Let's do it here. So we have 1010 as 10. So we have a dot here. So in right shift, you shift on this side, right hand side. So you will be losing how many bits? 2 bits, right? So you will be losing these 2 bits. So what is remaining is 10, which is this is remaining, right? And what is 10? It's 2, right? And that's why we got 2. So that's how you work with left shift and right shift. So that's your bitwise operator. So we have talked about complement, we have talked about AND, OR, XOR, and left shift and right shift. So again, when you do scientific calculation, this will be useful there. So I hope you are enjoying this series. Let me know in the comment section if you need some more improvement. Let me know on which topic. So that's it, everyone. Bye bye.